A star's lifetime and Pi's contribution to our discoveries.
From as early as 3000 BCE, ancient sailors made use of celestial navigation by precisely pinpointing the positions of celestial bodies to navigate through the open sea.
Stars serve an essential role to the life on Earth and development of humans. Our research aimed to learn about a star's lifetime and how the mathematical constant pi worked concurrently with astrophysics to aid us in our discovery journey.
Effectively categorizing physical properties mentioned in our research by the Morgan-Keenan classification system, which classifies the stars based on their temperatures and brightness. Temperature is represented with letters by letters with O, the blue stars being hottest to M, the red stars being coolest.
Following Jean's instability, interstellar clouds along with dust particles in a nebula collapse to form a protostar. Small protostars do not succeed in their star formation, becoming brown dwarfs instead. Following nuclear fusion, the protostar becomes a main star. After the end of the nuclear fusion, an average-sized star becomes a red giant, while a massive one becomes a red supergiant, a cooler and more expanded version of the star. The supergiant continues nuclear fusion, this time with helium, until its iron core becomes so heavy and evolves into supernova, leaving behind a collapsing core that will eventually either form a neutron star or a black hole. The giant turns into a planetary nebula that frays off its outer shells to become a white dwarf. Theoretically speaking, a white dwarf should later become a black dwarf, but the calculated time to do so is longer than the age of the universe. Pi is used for the calculation of many spherical and circular objects. We know that as the mass of a star increases, its lifespan decreases, and using pi, we can calculate the mean sequence lifespan and its mass.
As we're calculating luminosity, we can use an altered version of the Stefan-Boltzmann law, or the square inverse law that relates apparent magnitude to luminosity, both of which include pi. Through comparing Through comparing stars' absorption lines and keeping ionization in mind, astronomers were able to derive that stars' average composition is 90% hydrogen, 10% helium, and traces of heavy elements that are so minuscule they don't affect the ratio. In fact, the primordial ratio of hydrogen atoms to helium in our corner of the Milky Way is currently at 10. The light that a star emits is generated by a process of nuclear fusion, through which two nuclei come together to form the nucleus of a different element. From this chemical reaction, we obtain helium from hydrogen. Studying current and past stars is important, not only to the astrological field, but also the medical field, because the advanced technology can be used to advance current medical instruments.
Studying stars is more than just passing a subject. It is about quite literally looking into the past, figuring out how part of the universe and cosmos function, and learning more about the underrated celestial bodies that light up the sky and produce the raw materials that make life possible. Thank you for your
Thank you for
time.
your time.